From Sci News, early dinosaurs and their archosaur contemporary growth rates. From prehistoric to present, my name is Ethan. This is Creature Guide Live Daily News. Remember to like, comment, subscribe if you love talking about animals, and share this show with everyone you know. Now, let's get into the animal news of the day. Dinosaurs debuted on Earth stage in the aftermath of the Permian Triassic mass extinction event and survived two other Triassic extinction intervals to eventually dominate terrestrial ecosystems. So, the Permian Triassic extinction event occurred somewhere around 250 million years ago. And so far, it looks like the dinosaurs wouldn't start showing up until somewhere around 230 to 240 million years ago. More than 231 million years ago, in the late Triassic Igualasto Formation of west central Argentina, dinosaurs were just getting warmed up. At this time, dinosaurs represented a minor fraction of ecosystem diversity. Members of other tetrapod groups, including synapsids and pseudosuchians, shared convergently evolved features related to locomotion, feeding, respiration, and metabolism and could have risen to later dominance. Well, that's because the synapsids were the proto mammals of the time. We still had some that would occur within the late Triassic. This is not a synapsid, though. This is a member of the sauropodomorph lineage of dinosaurs. This is Chromagosaurus, which is of typical size for dinosaurs of this time. The sauropodomorphs and dinosaurs in general were somewhere around 3 to 7 feet in length, and this animal might have weighed as little as 20 pounds. And yes, this is very likely a predecessor to the later Macronenian long-necked sauropods of the Jurassic and Cretaceous periods. And this animal would have mostly fed on different species of plants. These are both very well done drawings. And unlike later sauropodomorphs, many of them would not be able to walk on all fours or be quadrupedal simply due to the fact that their forelimbs were not able to support their weight, such as the later Plateosaurus, which would evolve somewhere around 215 million years ago in the late Triassic. But this is somewhere around 15 million years before Plateosaurus would evolve. And these are possibly the predecessors to Plateosaurus. However, it was dinosaurs that radiated in the later Mesozoic most significantly in terms of body size, diversity, and global distribution. Elevated growth rates are one of the adaptations that set later Mesozoic dinosaurs apart, particularly from their contemporary crocodilian and mammalian compatriots. So, also when it's referring to the pseudosuchians, so these would evolve into different variety of reptiles within the Triassic as well as later into the Mesozoic era. Some of them possibly even evolving to certain types of crocodilomorphs. Let's see. Um, when did the elevated growth rates of dinosaurs first evolve? And how did the growth strategies of the earliest known dinosaurs compare with those of other tetrapods in their ecosystems? Yeah, I would think that these animals, such as the Eodromius, would have actually grown quite quickly. I would think, especially because this is a very small animal, and also due it to it being warm-blooded. Usually, with the smaller warm-blooded individuals, especially the theropod dinosaurs, I would think that it might have taken them somewhere between 2 to 3 years to grow up. Eodromius was somewhere around and some estimates have actually put Eodromius at over 7 feet in length. Originally, it was just thought to be around 3 to 4 feet. But this animal still didn't probably weigh much more than 15 pounds or a little over 5 kilograms. So, this animal also, when it comes to dinosaurs in general, many of the earliest species were probably carnivorous, though you had the earlier sauropodomorph species as well. This individual was probably just preying on smaller species of insects, maybe going after smaller amphibians or reptiles, probably not hunting any other dinosaurs within the region unless they were hatchlings, but possibly did feed on smaller species of synapsids or mammals. In new research, paleontologists studied bone histology of an array of early dinosaurs alongside that of non dinosaurian contemporaries from the Ishugualasto Formation in order to test whether the oldest known dinosaurs exhibited novel growth strategies. Their results indicate that the Ishugualasto vertebrate fauna collectively exhibited relatively high growth rates. Well, this seems to make sense. What's interesting about this is that you have the certain proto-mammals of this lineage, especially the larger Dicynodonts, which could reach over 2,000 pounds. But just their overall morphology, you would think that these animals would have had quite slow growth rates. But since these are warm-blooded animals I'm talking about, very close related to mammals, I guess it makes sense as to them having a quicker growth rate. This is possibly, oh, okay. It's a Herrerasaurus. It's quite a bland one. I mean, usually some have reconstructed Herrerasaurus and the Herrerasaurid lineage of theropods in general to be somewhat feathered, and others have just added different types of osteoderms along their body. But this, it's mediocre. Now, if it's just referring to the painting, yeah, it's a great painting. Anyway, I'll keep going. Dinosaurs grew up fast, a feature that likely set them apart from many other animals in their Mesozoic ecosystems. Um, so when it comes to animals such as the sauropods or the larger species of theropods, as well as even certain species, ceratopsians and kylosaurs, these animals might have taken somewhere between 20 to 30 years to fully mature. But there were instances, especially with the sauropods, many of these larger animals would have continued to grow throughout their lives, but at a much slower rate. And yes, they were all warm blooded. Some paleontologists, oh, well, let's check out somebody else. So, oh, wait. Yeah, I'll do him first. So, this is Ishigualista, which is the animal that this formation was named after. This is a member of the Stachyristidae lineage of Dicynodonts, so it is a very close relative of the Placerius, which is probably the most famous Dicynodont. And this individual weighed somewhere between 1,800 to 2,200 pounds, or somewhere around 900 to 1,000 kilograms, and was an herbivore. This animal, and yes, this is a picture of Batoy. It's just a really good reconstruction of Isha. Um, they were toothless, but they still probably fed on a wide variety of different species of ferns, maybe even going after specifically horsetails. Might have even fed on different types of semi-aquatic vegetation, but it was not going after any animal protein. It probably had to be concerned about the different crocodilomorphs that would have inhabited the region. Not so much the dinosaurs, though, at this point, considering the Ishuaqualista formation ranges between 225 to 231 million years ago. And at this point, the dinosaurs, even the carnivores, weren't really much of a threat to a 2,000-pound animal. Some paleontologists have proposed that these elevated growth rates were key to the global success of dinosaurs, but little is known about the growth strategies of the earliest dinosaurs. The question is how did they become all of a sudden extremely large? I'd say by the late Triassic. What I mean by that is somewhere around 3 to 4 tons, especially with animals such as the Plateosaurus. The carnivores, though, at that time still weren't quite large. I think 1,000 to 1,200 pounds or somewhere between 500 600 kilograms was a pretty large theropod at that point. But then by the early Jurassic and then the mid Jurassic is when you start reaching much larger volumes. In a new study, Macalester College researcher Christina Curry Rogers and colleagues performed histological analysis examining patterns of bone tissue growth in the fossilized leg bones of an array of animals in one of the earliest known Mesozoic ecosystems. Okay. The studied fossils come from the Ishuaqualasto Formation of Argentina and date between 231 and 229 million years ago. Okay, so it's probably referring to a certain group, or it is, of this the Ishuaqualasto Formation. Sample many when Fossil formations of Argentina relating to the Mesozoic are talked about. It's usually referred to the ones that link to just about 5 million years of the late Cretaceous period, especially in the earlier parts of the late Cretaceous, the Turonian stage. In this areas where you had the larger Carcharodontosaurs, such as Mapusaurus, as well as the large Titanosaur sauropods, such as Argentinosaurs. But the Triassic formations of Argentina are much less talked about, as well as pretty much all the other formations. Okay, let's see. Sampled fossils include several of the earliest known dinosaurs, as well as several non dinosaur reptiles and one early relative mammals. So let's take a look. This is a member of the Idosaur lineage of archosaurs that existed during this time. This is Asteroides, and this was not a carnivore either. This was actually an herbivore that existed during this time. So this is the Asteroides. Now, it is possible it might have been it might have been omnivorous, so going after different species of insects certainly is possible. But most likely it was just feeding on different species of plants as well. This individual was probably around 7 to 11 feet in length, around 2 to 3 meters, and did have to be concerned about the crocodilomorphs within the region and possibly the larger theropods. But when it comes to theropods, definitely the descendants of animals such as Asteroides, because the Idosaurs did become much larger, like as they became Desmatosuchus, and they would have had to have been more concerned about, especially the Herrerasaurids. Also in this area, not you. Oh, is the Pelorocephalus, which is a member of the was it Jugosteridae lineage of the temnospondyl amphibians, which first evolved in the Carboniferous somewhere around 310 million years ago, and would end up going extinct at around 100 and somewhere between 125 and 130 million years ago in Australia with Coolosuchus, and they are one of the probably the closest extinct relative of modern day salamanders. So here's just a reconstruction of this animal. It's probably around 6 feet in length, around 2 meters, and was probably feeding on different species of fish, maybe even certain aquatic insects. So let's see. Being able to look at the same area of the same bones and all the animals we sampled was an important part of our study. Most of the times when we study growth rates in any fossil animal, our samples are opportunistic. Often, this might mean that samples come from very fragmentary specimens that don't hold a lot of anatomical value otherwise. Yes, this can happen with a lot of, I'd say most fossils. It's quite rare where you have it where you can um, figure a lot about a certain animal's behavior due to just how intact a certain specimen is. When they're quite fragmentary, it's quite complicated unless you find a large number of that specific species or even other animals within the region in close proximity to it. You may only be able to sample a shin bone from one animal, a thigh bone from another. Well, what I'm referring to is that you have the thigh bone. They're making out like you have an intact thigh bone or a rib, and what I mean is that there's only bits of the thigh bone or the ankle bone, which happens with many species of new dinosaur that happen to be found, unfortunately, and a rib from yet another. But since each of these bones does a different job in an organism's body, such a diverse sample might be telling you a slightly different story about that animal's growth history. To be very specific about comparing growth patterns among different kinds of creatures, it's best to sample the same bone in the same place and from the same environment. So let's take a look at somebody else. So this is Exirtodon. So this is a member of the Cynodont lineage of proto-mammals of this time. So this is a synapsid. This animal was somewhere around 4 to 5 feet in length, or about 1.7 meters, and was also an herbivore. Unlike many of its kind within this region, which were actually quite carnivorous, this specific synapsid ended up taking on an herbivorous lifestyle, which is quite unique. Many of the cynodonts within this region were quite carnivorous. This, I believe, is a distant relative, considering the Ixarctodon does not have this distinct dental structure and even a different type of a physique. So, is there anybody else? No, it's the Telocephalus. So, let's see. Where were we? Okay, for this study, we sampled only the largest known skeletons of these animals in hopes of getting as much of a complete growth record history that we could. We also constrained our sample to a very narrow time window in the ancient past so that we weren't dealing with the background paleo environmental change that might impact what we were seeing in the bone tissue. These controls gave us a really unique perspective on comparability across this dinosaur and non-dinosaur group. Well, the question is like, what exactly have they found so far? Because it hasn't really mentioned a whole lot. Mainly just that they're having trouble like normal. So it's here. Let me see. Um, Oh, okay. It's going to catch on. The authors found that most of the examined species had elevated growth rates, more similar to some modern day mammals and birds than to living reptiles. Well, that seems to actually be the case with a lot of findings of growth rates within the dinosaurs, the other branches of Archosaur, and the Archosauromorphs is what the dinosaurs derived from, as well as modern day crocodiles, alligators, um, well, technically you could say crocodilians in general, and the birds. All the other reptiles were not descendants of archosaurs that exist today. So let's see. The early dinosaurs all exhibited particularly fast growth. Yeah, that seems to make sense. But they weren't alone in this, as similar growth rates were seen in several of the non dinosaur reptiles as well. So this might refer to for instance, the Idosaurs. It might have also referred to even the Dicynodonts within this region. So, who else? The wide variety of like the Rausuchians existed here, the Pseudosuchians, so relatives, the crocodilomorphs. These results show that the earliest dinosaurs were already fast growers, supporting the idea that this feature was important to their later success. But apparently, dinosaurs were only one of multiple lineages evolving with elevated growth rates during the Triassic period, suggesting that this feature is only part of the story of dinosaurs' eventual global prosperity. Um, yeah, I would say that especially the plateosauromorphs or the sauropodomorphs at this point were growing quite rapidly, especially the small little, 6-foot individuals. Even as you got to the 26-foot long Plateosaurus later on in the Triassic, um, I wouldn't doubt that it would only took 4 or 5 years for that animal to fully mature, possibly a bit longer. But what it's not mentioning is definitely like the marine reptiles in the ocean at this point. Also, a bit later into the Triassic, you had immense ichthyosaurs. So these were somewhat dolphin-like reptiles that existed in the ocean like, well into the Cretaceous period. But you had the members of like Shastasauridae, which could reach over 120 tons. And the question is, how long would it take for these individuals to grow? Let's see. Future studies could expand on these preliminary results by sampling a wider variety of ancient animals from additional early Mesozoic fossil sites. Our sample comes from a time in which dinosaurs were the new kids on the block, restricted to relatively small, basic body plans, and evolving within a world rich with a diverse array of more specialized non dinosaur reptiles. I wouldn't necessarily call it a basic body plan. I mean, this was the first of its kind to evolve at this point. So um, I think I'd consider something like maybe a shark to be kind of basic. I'm also talking about marine animals. We tackled the question of how all these animals grew and found that the earliest dinosaurs grew quickly and that these rapid growth rates probably played a significant role in dinosaurs' subsequent ascent within Mesozoic ecosystems. But dinosaurs weren't unique. Many of their non dino sidekicks shared rapid growth 230 million years ago. No, I'd still consider them quite unique, considering they still would have had, even though many of these Archosaur lineages would have had their hips not necessarily splayed out to the sides like a crocodile or an alligator today, but it still wasn't in the same type of form that you would see in something like a Tyrannosaurus Rex or a long-necked Brachiosaurus. In fact, when you look at a wide variety of these different forms of just dinosaur alone, animals like Stegosaurus and Triceratops were very different from each other because technically, when you're looking at the three-horned Triceratops, it's a very stiff animal. Whereas Stegosaurus, on the other hand, was one of the most flexible, if not the most flexible of any dinosaur. So I'd say that there was more variety in just the overall like locomotion and morphology of the dinosaurs than possibly the other archosauromorphs combined. So, it's good to hear that this has been confirmed. And let me know what your favorite species of Triassic animal is within the comments. And from prehistoric to present, my name is Ethan. This is Creature Guide Live Daily News. Remember to like, comment, subscribe if you love talking about animals, and share this show with everyone you know because nothing is better than all animals all the time.